Hi, I'm Chris at 9CVR. In this video, we're going to do a lot of soldering. So first, what is this thing? This is a Nino TNC. So it's a terminal node controller used for packet radio, APRS, stuff like that. And basically in this video, we're going to be building this. This comes as a kit. So you get the board and the chip for, I think it's about $12 on Etsy. And then everything else you can actually get as a bill of materials through, I think it's Mauser Electronics. Total cost of the build is maybe 40 bucks. Yeah, 35, 40 bucks, something like that. I'll warn you, it's a bit longer of a video. There's a lot of stuff on there. It's going to take a while to solder it. This is not something that you buy, my first soldering iron on Amazon and go, I want to learn how to solder, let's do this. But it's going to be a cool project. So stick around, let's start building it. All right, so here's the board. This is what we're going to build, or populate, rather, I should say. And right next to me, I have the rest of the instructions. So, actually, I'm probably going to need to use this thing as well. Yeah, something like this. That should make it very nice and easy to solder most things. And then this is the sound of a box being opened. Looks like a shoebox, except it came from Mauser. So that's kind of cool. There we go. All the stuff. Big old bag. So let's open her up and see what we got. Oh yeah. Gotta use the knife already. Actually going to move this out of the way. I'm going to move this chip out of the way so I don't lose it. And we don't need this. But yeah, that's all the parts. Way I got all these parts is if you go on tarpon.net, I'm going to pronounce it. Tango Alpha Romeo Papa November.net. They appear to kind of be the I'll call it the gatekeepers of knowledge of the Nino TNC. I'm not sure if Nino works with them or what. I didn't look into that. But anyway, they have a very detailed assembly manual online, so that's what I'm looking at. So all these different parts, I suppose I will sort through them all, figure out what I have. So I'll be back. So that took a little bit, but we are ready to go. Well, I've organized about half of the components. Sorry for the squeaky chair here. By the way, there have been a couple of recent comments
about, I'll call it both the sound and the videography that I'm doing. This is absolute bargain basement. You can see the shadow of the phone that I'm using, and you can see the legs of the tripod. So I guess let me know how it's going. That's something I'm working on. It's slow. It's a process. I know it's not professional quality. I have actually used to work in commercial radio. I know my audio. My video, you could argue. But it's kind of what we're at right now. So as improvements get made, let me know. If you're curious, I will have a link in the description to the assembly instructions I'm using. So I'm literally just going to follow the instructions. I've got piles of components here, and we'll just start populating the board. Without further ado, step 1 says Y1. Y1, here it comes. There's Y1. Y1 is a 7.3728 megahertz crystal. It's pretty. And it lives right here. So then what I'm going to do, I'm going to hold it down, rotate this, and bend the legs just a little bit so they stay. Maybe a little more. There we go. That stays. Sure, I can start putting the, let's do this. Put the solder over here. Let's let this guy warm up. I don't know what this is supposed to melt at. Probably less than 780. Let's try. Oh, come on now. I don't know, 725? Let's try 725, see how it does. I don't know what to expect. Oh, it melts. That's good. And my tip is obviously too big. So actually, I'm going to shut this off. I have a couple nice, very small tips. There's a very small tip. Don't say it. Where are we going to put this so it doesn't cause problems? Put it right there. And we will use this. Do we want to use this flat end or do we want to use the pointed end? I'm going to use the pointy one. There we go. Try that again. There we go. Let's see what it warms up to. $725. Cool, it remembered it. All right, so let's try this again. So immediately my first thoughts are these are pretty tiny little through holes. It's all right, nothing wrong with that, but And then I'm going to come in here and snip these ends off. Note that I am keeping them. Excuse me. I saw some comment later on. Actually, I'm going to put them off to the side here. I saw some comment later on that we may be using some of the leads for future stuff. So I am seeing that the crystal is not quite straight in here, so I'm just gonna remelt that solder and push it down a little. There we go. That's a little better. Okay. That's step 1. Here's step 2. There's 4 resistors. R's 4, 15, 16, and 17. And they are 5-band resistors. Oops. Yeah, just bend all of them. There we go. 5-band resistor color codes is something I'm not good at, so I am trusting that these are indeed the values they say. We shall find out. All right, let's find R4. Maybe some hunting around on the board while you all scream at me like, it's there. Okay, I'm seeing 11, 15, R4. Here it is. Okay. So I just bent it down like this, and that's not good enough. We got to probably actually use pliers to give it a nice little bend. Gonna give this end a shot here. Like that. Leave the pliers here. Let's see if R4 fits in here now. There we go. R4. R15 is just a little over from it, as is R16. So again, I'm just using the Leathermans to kink that edge of wire. There we go. So I'm going to skip right to 16 because it's right here. Then 15 comes next. There we go. Again, we flip this over and bend the leads out so that it doesn't fall out. Rinse and repeat. I should mention, by the way, I'm not a solder technician. So if I'm doing it wrong, I guess I'd be kind of curious to hear that. As long as you kind of tell me what I should be doing. If the answer is get a $1,000 or multiple $1,000 solder gun, that's not going to happen unless you buy it for me. I do have a Patreon. Like how I slip that in there just like that. Link below. R17. Oh, that's nice. Now that I've put all 4 of these in, I just noticed in the instructions, it actually gives you a really nice picture with the whole board grayed out except for these 4 resistors. So you don't actually have to go hunting across the board for it. Useful if you're more observant than I am. Okay. fully understand that I am a child, a mere fetus when it comes to ham radio operators, but you know what? I think I'm going to start needing to get some reading glasses pretty soon here. There we go. All right. Step 2 mainly complete. Step 2 reminds me a channel that I rather enjoy watching if you're into camping stuff. The guy's name is Steve Wallace, Whiskey Alpha Lima Lima India Sierra. He has not posted too much recently because I feel that he's gone through a lot in the past couple of years. But great camping channel, a lot of fun, low key. And if you get why I bring that up for step 2, then you get it. If you know, you know. On to step 3. This is R10. Getting it out of the bag is a little challenging, but we got it. Kind of going to be rinse and repeat. Bendy, bendy. Pokey, pokey. Soldery, soldery. There we go. Again, I'm keeping those offcuts because I heard rumor that I'm going to need them. All right, that was step 3. Step 4 is R11. Now it warns you here that this one's blue. There are brown ones as well. Doesn't matter which one you get. Whatever works. Bendy, bendy. Pokey, pokey. And we'll solder it home. It's about as good of a solder joint as I could have ever asked for. There we go. All right. Step 5. R12. This works really well if you actually like sort through your components first. It's probably one of the bigger soldering projects I've ever undertaken, so I'm learning here as much as anybody else, but here I've tripped across a good one. Okay. R12. They tell me it's right here. Wow, that's good. I was literally just looking at the picture on the instructions. All right. Again, I do not claim to be a solder technician. I'm not saying I'm doing this right. I am kind of wishing I'd grabbed that little flat-bottomed bit tip. I feel like that would have worked a little better. This one's got such a fine little tip to it that I feel like I have to place the side of it on whatever joint I'm soldering instead of being able to hit it at an appropriate angle. So your mileage may vary. Okay, that was R12. Now we are on to step 6. R13. Oh, let me show you a trick I just learned recently. You take these bags and you pull really hard. Sometimes you'll, if you can get them open, that works. The other thing you can do is, and I just learned this, so maybe it's common knowledge, but you take it like this, you pinch and you slide it, and it pops right open. Goes a little quicker that way. I thought it was cool. All right, so again, gonna bend it. This is R13, which is way over here somewhere. Here it is. Yeah, they make this like bulletproof with the pictures. It's pretty great. There we go. Bend. And we got a friend joined us. Puppy. There we go. So that was R13. Let's go on to R14. This is step number 7. See, some of these I already cut open because they have staples in here. Hi, dog. There we go. R14 happens right here. Here we go. We're burning along here. R18. It completely doesn't matter, but I do think it is really, really, really awesome how so far it's turning out all of these resistors are blue as is the board. It's dumb, I know, but I think it's cool. It's just kind of what got given me here, but I'll take it. It's not what's in the pictures. R18 is over here. The amazing part to me as well, I keep saying this, but these instructions, like, I did not stop and study the board to know where all this stuff is. You saw me struggle with the first one. The minute I figured out that they have put these shaded pictures of where the stuff is supposed to be, it just makes it so much quicker. That was really, really good thinking on their part. There you go. Hi, flea bag. Somebody wants to get high off the solder fumes. Okay. R19. R19, I did not look where it goes. So it goes right here. I am breezing through the soldering of this pretty quickly, but I should mention with every resistor here so far, they have a little explanation of what it does. I'm just kind of not paying attention to them right now. So this one says R19 is part of the amplification circuit for receive audio op amp. One of the signals switches, 1x/11x, bypasses this resistor. If this resistor is bypassed by the switch in the up toward the edge of the PCB position, then the gain on the amp is 11. If it's down, it's 1. So it explains everything, which is kind of cool. Or it's explaining a lot so far, let me say that way. All right, what do we got next? We are moving on to capacitors, C4 and C5. Bluey. Comment if you get that reference. Ugh. I hate these little paper things. These are coming out easy, actually. Surprised. Okay, let's flip back around. C5, I see C5 right here. And C4 must be right, yep, right here. So notice they've set this up so that you you build from the lowest profile to the highest profile is kind of the idea. So I probably don't even really need to be using this helping hands, but they're nice, you know. I was given them, so may as well use them. Come on. Okay, this is, yeah. There we go, something like that. It's not the prettiest solder job ever. Again, I am saving all of these leads for now. Most of them will go in the garbage. A couple are needed. I'm sorry, this one is really ugly. Yeah, there we go. There we go. That's a little better. Okay, so that's C4 and C5. Next up, C8, C12, and C13. See if these pull out okay like this. Nope. Okay, so then what we do is we reach into the pocket for the pocket knife. And what I do is I slit like this. And it comes right off, and then you can just peel the masking tape off. So we'll do the rest of that. It is of vital importance to do this in a manner that does not slice your fingers open. I don't know what I was doing there. I was like looking for a liner lock here or something. Like, I mean, guess I never did claim to be the sharpest tool in the shed. Go. Okay, C8, C12, and C13. C8 sits right, no, that's C13. Okay, well, C13 sits right here. C8 is right here. And C12 comes right here. Okay. There we go. And give each one just a little dab of solder. I think I need a little more. Let's do 750. Because basically what's happening is the, there we go. The component isn't heating up enough, so the solder just sticks up the, tries to ride up the tip of the soldering iron. which is not ideal. Yeah. A little more temperature and we're a lot happier. Okay. All right. That was part 11. Now, we open a MOSFET. Observe precaution, electrostatic sensitive. Who cares? Right, no, we care. We care. I don't have a good place to ground myself though, so we are going to just risk it. Okay. This would appear to go right here, Q1. And okay, so this has two legs that are kind of glued together and two legs that are separate. The two that are glued together go up top, according to this picture. So we're going to use the picture. It's going to go here. I have a bent leg. That's kind of not cool. Let's see if we can unbend it. There we go. Now it fits. No, I have two bent legs apparently. There we go. Took a little persuasion, but we got it. Now they're saying bend one leg over to hold it. Well, I'm apparently not needing that. It's holding, so we're just going to give it a bit of solder. Get some solder over here, here, and here. There we go. A lot of explanation of what this particular chip does, which I think is kind of cool that they do all of that for you. All right, now we're gonna have some fun. This is the socket for the CPU. So I will be spending the next 5 minutes just back and forth on this. Goes like that. What I did is, I don't really have a good way to point, but here's this little indentation. There isn't one over here. That matches the one on the board. And now we're gonna have fun. I am going to have to bend probably 2 pins over. So that's what I'm trying to do carefully without wrecking it. Almost wrecked it. And now we're just going to go down the line. 1, 2. I'm not going to count all 18. Did I say 18? It's 28. 28 pins, 14 on either side. Oops, there we go. Well, that took a hot minute. There it is. We're now at step 14. Another static sensitive component. This is U2. In the name of... I'll stop. Okay, I'm sorry. You did not need to hear that. Now this guy lives, it's a regulator, and it lives right here. Oh, of course. So you see these three pins are not in line, whereas they are in line on this case. So I got to do a little bit of funkiness here. I'm just bending it back just a hair. Stick these two in. There we go. And now I'm kind of going to use a bit of persuasion to get it in there. There we go. Something like that. My singing is bad enough. Can we call it a parody? I think we can. I just don't want to lose subscribers by doing it again. Okay. Step 15. Here we go. This is a resistor network, a resistor array. And this would appear to live right here. From what I see, I don't... Oh yes, it does matter. Okay, orientation is important. Glad I looked. So what I'm seeing is this little symbol here, the dot, goes into this hole. So it has to go in like this. Now we'll do that. Come here and bend this one over. Bend this one over the other way. And send them home. Okay, these helping hands are actually starting to get in the way. Just adding a little more here because I feel like I didn't quite do it justice. Oh, that looks good, I think. There we go. So that runs me out of parts. I'm through step 15. So I'm going to break for a little bit and move on with step 16. Okay. I almost ran myself out of memory. But here we are back at step 16. So here we go. Step 16 is these two capacitors. They are metal film capacitors. C17 and 18. Step 16, C17 and C18. Confusing enough? There we go. These have only a marking on the top. So, yeah. Okay, well, there's C17. Do that, bend them over. Gonna have to hold these guys in. And C18, here we go. When Smokin' Ape did my fuse block build, he had a really cool trick using what's it called? Blue tacky, you know, the stuff you use to stick to walls, and then you wonder why your walls are blue. And that seemed to work really, really well for him. I don't have any with me, so we're just going to do it this way. Like that. Now I'm going to heat it up and push in on it, and there we go. That one's good. Do the same dealie here. Like that. Push in, let go. We're good. Do the other side. Again, I feel like I'm just running into a little bit of a problem with this particular solder tip. I should have picked one that's a little less pointy. Oh well. There we go. Let's snip these guys. There we go. All right, there's step 16. Step 17. C's 2, 3, 11, and 15. Here they come. Now these guys have polarity. There we go. I'll show you the polarity in just a second. Get that crap off of there. Okay. So there's tiny little lettering and all that stuff. Then there is a line over the top, and then it comes down here to a tiny little plus. So the plus goes to the plus side. And again, they've showed us the pictures. So there's C15. Again, the plus, so I actually have it oriented wrong. It's got to go this way. Or just completely fly out the other side. Now, this is interesting. The leads are not quite the right size. So let me read about this. it says absolutely nothing. So I think what I'm going to do is I'm going to use the pliers, bend them out a little, bend them back in. I don't know, something like that. Then again, we got to make sure the polarity is correct. There we go. Close enough for who it's for. So I'm going to do the same thing over here again. I'm going to take this, bend out, bend out, bend back in, bend back in. Plus this way. Let's find C2. Okay, plus goes this way on C2. So I think what I'm kind of seeing with this is this should probably not be somebody's first soldering project or first kit. That being said, whose first kit would be a TNC? So sorry if there's some background noise. I'm in the basement today. And we have had a bunch of snow and rain and all sorts of things like that. And we are hearing the results of it. Okay, so again, there's the plus side. The plus side goes in here. There we go. So there's my 4 capacitors. Oops. And let's solder them home. It's interesting. Little chunk of something there that came off when I soldered. Came off, so it's not a big deal. But okay. All right, that was a long step 17. It's okay. There's a big long commentary. Sorry about the silence there. I'm reading this big long commentary on what the soldering should look like and all of that. But okay, whatever. Step 18 is 2 variable resistors. There we go. They're also called potentiometers. They are called potentiometers. Let me rephrase that. They sit right over here, and they just go like this. So stick them in. Happy, happy. Bendy, bendy. I think I'm just going to solder each one at once. I don't know how true this is, but I had a buddy a long while back. It's actually one of the two guys who got me into radio. We used to work at Radio Shack, and he said there was kind of an unspoken policy there that if somebody came in asking for a variable resistor, they wouldn't sell them one because they were used for, I would say it was stealing cable, something like that. Building a cable splitter to steal somebody's cable. There we go. There's our other variable resistor, potentiometer. Maybe it's a variable potentiometer. How about that? It's kind of like the Sahara Desert or an ATM machine. Oh, well, I still got this. Let's just make sure these are seated nicely. There we go. Okay. Now step 18, 19 coming up here. A single capacitor. There it is. C6. And again, they very kindly show us that it goes right here. Okay, fine, I'll snip those leads. They're just a hair long. There we go. Starting to look like a populated board, huh? Step 20, here's another one. C9. Oh, they stapled the bag shut. Why do you staple the bag shut? There's no need for that. There we go. C9. And that goes right here. Does not appear to be any polarity to this, so we're good there. There we go. Step 21. C's 7 and 10. There we are. Here, little boys. And I guess they go right next to C9, so we'll do that. Oh, they're tiny, tiny, tiny. There we go. Stick the next one in. And give her. There we go. All right, there is a comment here. Yeah. There's one capacitor left over. 0.15 microfarad. It would be C16, I guess. It says we'll use it in one of the last steps. Okay. Here it is on the side table. Now we get to some fun. Step 22. We're going to unlock some possibilities. This is a USB-B connector. Okay, now I got to rethink how I'm going to position. Maybe if we try this, something like that. There we go. And here's my USB-B. Oh, that's very kind of them. The way they built it, it just clips in. It's like super easy. Solder all 4 pins. And then, there we go. Let me do this carefully so I don't bridge any solder. We're good there. There we go. And now these guys, they call these support items. Okay, support items. Support pins, maybe? That's what I would have called them. But I'll go with it, support items. And we got to pause a little bit again because we have just completed step 22. Before step 23, we have a regulator test. It says now that the USB connector is on the board, 5 volts will get to the board. It will be regulated down to 3 volts by U2. I'm sorry. And then it will show up at the CPU socket pins 27 and 28, which are these two down here. They're showing. No, sorry. They're these two. So we're going to find a USB power source. We're going to find a USB cable first. I hope I have a USB-B cable. And we're going to test it. So I'll be right back with that. There we are. Plugged in. It's on. Oops. There's my meter. Now we are looking at, I guess they don't care about polarity, they care about voltage. So we're going to do this. Three volts, huh? I'm not seeing 3 volts. All right. Inspect the USB connector. That looks good. U2. And that. Stop it. Stop it, Chris. That's stupid. C3 looks okay. And then the other thing they say is look at U3. U3 looks fine. So I'm not sure why I'm not getting any voltage here. Let's try this. I have a whole bunch of different USB options here. And I don't know, maybe the one I picked is not good. So we will try this one. Oh, you know what it is? I checked the wrong port. There we go. Okay. I'm seeing 3.290 volts. Observe something between 3.00 and 3.60 volts on the display, and this should be within 0.1 volts of U2's specification. Well, 3.291. I like it. So there's that little test. So I suppose they should have written down here, if this test fails, inspect the person operating the test equipment. No, joking aside, what threw me off, I'm going to unplug this for a second. What threw me off is, so they have this set up in the picture, so you're looking at it like this. So yeah, that gets awkward. I thought I was looking at the wrong pins. So we're all good. We're all good. Let me grab my USB cable because I will be needing that later. On to the next. So this is step 23. I'm burning through this. These are 2 mini switches. And they're saying make sure to install this correctly. So, mode, right here. According to their documentation, get in the holes. There we go. This is the correct orientation here. Signals, again, this here is the correct orientation. I realize you can't see it because my big fat fingers are in the way. But I'm trying to get, there we go. So these are the correct orientation. Let's send them home. Come on. There we go. That wasn't quite enough solder there. Okay. And we are good. Excuse me. Step 24 is this little switch. Which sits right here. And again, I'm just burning through this. There's a whole explanation of what each individual part does. I'm just trying to get this thing built. You can read up on that in the link below. So there we go. There's a little switch. All right, here we get to the fun part. Step 25, D1, D3, D4, D5, and D6. These are all LEDs. I'm going to leave one in there. That is D1 here. Now, part of the reason I pulled this plug here is because they are showing to bend this correctly. What we're going to do is place it across the edge of the USB-A like this, and then use the corner as a template to give it a little 90-degree bend. So you should end up with something like this. Now we are going to get into this awkward part of the video where I'm running out of room on my board to hold it. So I think what I'm going to do is adjust like this. That looks good. Okay. And now let's see, how bad did I screw this up? Because there's also a polarity. The polarity is such that the short wire goes in the hole with the square pad. Oh, dude, I got it right. That was blind luck. No, I'm that good. I'm that good. Yeah, no, totally. I'm that good. I'm good. Okay. There's that. Let's get D2 now. This is a yellow LED. Oh, they're wanting me to bend the leads so it stays. Fair enough. We'll do that. Okay, the other thing I want to see is grab the USB-A. Short lead should be on the cable side. Okay, so cable side, short lead, we're doing this. And we push it up against there, and then we give it the little 90. Just like that. Before I solder it in, though, or before I put this one in, I'd like to solder this side. I would feel better that way. So I will do so. Sitting nicely. I like it. So we're going to clip the leads. Next one should be yellow. D3. Same deal. Short lead goes in the square hole there. Gonna bend these. This is where Ape's blue stuff would be really, really handy. There we go. I'm noticing this one's sticking out just a hair further. It's just going to be what it'll be. Okay, I believe the next one should be green. There it is, green. Same thing, short one. It's going to go to the cable side, just like this. Push it in and bend it down. There we go. Next one. This should be clear. What color does it? I don't know. WLTMRW THT. Yeah. I don't know. We'll find out what color. Hey there, little guy. There we go. Didn't want to come out of the package. All right, same deal. Short side toward the cable. I'm gonna grab it and bend it over 90 degrees. Now this one's interesting because it's got these little chunks there that kind of get in the way of the bending, honestly. That's all right. I think we've kind of mostly made it. Send her home. These, sorry, I'm not talking much here, but these LEDs and the bending of them is actually not trivial. I feel like I'm, well, you can kind of see they're lumpy. They're not exactly where I would want them all to be in a row. This way, looking head on, they're okay, but they're not great. This is not easy, especially with this. What color is it? I'm curious now. Blue. It is a blue LED, and with those little chunks that they've added on there, that makes it more challenging. All right, here comes D5, the last red LED. Same deal. Come on. Go like this. And bend to get a 90. And I screwed up. So here we hope that the wires are of decent enough quality that I can get a second bend out of them. Try it again. I guess. I think I managed to do it. There we go. Okay. Solder them in. Okay. Something like that. That is not by any means my best work. In fact, it's kind of downright ugly. From head on, they look okay. Yeah, this is not my best work. If I were to rewrite the instructions, I would probably. It's cool to use the USB-A as a guide, but then basically I'd have people come in and grab the. Oh, that's not going to work either. I almost feel like you need a little 3D printed template. That would probably be the way to go. Make a little 3D printed template, stick it in there, bend it, and then you're good to go. That's, I think, how I would do it. because this leaves a lot to be desired. Okay, here's where they say save the trimmings for later use. It's all in red, bold, all of that. Okay. We did all of that. Step 26 is a cool one. Here we are. This is our CPU. Remember that divot over there? There's a divot here. Gonna carefully place this. And I'm sorry, this is one of these things. I have to be able to see it so I don't wreck anything. There we go. Click. Look at that. Ha ha ha. All right. Test procedure. There is a test procedure. Let me plug my USB back in. I will likely need it. Actually, not likely. Definitely. I will definitely need it. Here it comes. There's my USB. And this is going to be a read and then do. It says, attach the USB to a powered socket. I did that. Plug it in and observe the LEDs. The first time it's powered, it will execute a program related to field programmability. During this process, the green LED will be lit and will flash. And it actually has a little GIF later that shows you what it's supposed to do. This will last under a minute. Let this finish before removing power. If on first power up, no LEDs illuminate, leave it powered up for a minute anyway. To let the CPU finish its housekeeping, this is only necessary the first time the CPU is powered up. After it's powered up, and normally after any other power up, well, I think we can plug in at this point. So let's rotate it. We're gonna plug in. Let me get a clock up so I know how long it goes. Clock. Online clock. There we go. I'm not seeing any green flashing LED, but they told me that's okay, so we're gonna wait for a minute. So after the first time it's powered up, and normally on any other powered up, the CPU will drive 4 of the 5 LEDs through a sweep back and forth, which is handy to prove that those 4 LEDs are installed correctly. Depending on the mode switch, the cycle will run once or repetitively. Start with it set to 0000, which it is. That's this. Which would have all the switches pulled down, yes. Switching any of the mode dip switches will again cause the LED sequence to repeat once or indefinitely, depending on the switch. Then he recommends moving the switch closest to the LEDs, causing it to repeat once. Trying to see what else here. The TX should not have illuminated. All 4 of the others should have. So TX is this one. So all 4 of these should go. Okay, it's been a minute. It's been a hot minute. So I believe I can unplug it. Let's give it a shot. Unplug. And now I will plug it back in, and hopefully I'll see this, like, it goes, starts here, goes out, and then comes back. It's kind of, or no, sorry, here and goes down to red and then back to yellow. So let's try it. It did it. Cool. Awesome. So, let's see, they are recommending I switch this guy on. Causes it to do it again. Causes it to do it again. That's good. I'm gonna come on. Use a cable to do that. So that was good. 0001. There it is. Cool. Oops. All right. So now, next operation, PTT light test. Should prove that the CPU can individually operate the PTT LED. That is, it's not clear which one. I'm assuming this one, but the test will make the CPU think it is going to transmit a packet. That will cause LEDs other than the red LED to flicker as well. Okay. Press and release the test TX button slowly several times and demonstrate that the PTT LED can be illuminated and it is independently operated by the CPU. Releasing will cause a blue TXQ LED to illuminate in addition to the red for a brief period, and that's okay as long as the two aren't tracking each other exactly. So there it is, and that flashed. Looks good to me. If all 5 LEDs were made to illuminate independently, and the mode dip switch caused the 4 LEDs to cycle, you're good. Skip to the next step. Nice. Okay. So we are on to step 27. I am momentarily here going to assume that I should unplug this before working on it any further. There we go. And now we are going to start making these loops here. So here's one as an example. And here's where we grab some of this wire here. Sorry for the left-hand reach. I don't know, we can use this guy, I guess. And I'm trying to figure out is how far in do I have to go? Probably about here. Something like this. And I'm going to bend and bend so that I get this like staple looking thing. If I did this right, it should fit right here. And it does for the most part. There's a bit of solder on the end of it, so I'm just going to heat that up, hopefully melt it. I don't know if I did that or not, or if it's sticking for some other little reason. Here's what I'm going to do. I'm going to take pliers and just cut it off. There we go. Stick it in again. Now this is going to be fun. I got to do a couple things at the same time. Okay, I'm going to do it that way. What happened here? Did my soldering iron turn off? Yeah, it turned off. got sick of it. Decided it didn't want any more. Okay. So now we're left with this little loop. It's not a great loop by any means, but it's a loop. Okay, if I go over by signals, there's two more. RXA and TXA. So I'm going to try to find some nice long wires. Let's try this one. Same kind of deal. If I go, what's that? 7/16 of an inch in, something like that. Seems like I get the right width of staple. Then I can stick it in. Or I can't stick it in. Here's the other thing about this kit. It definitely appears to require a bit of manual dexterity. There's that. Send it home. There we go. That's a much nicer little loop. We're going to try to do the same thing on the other side. Pick a nice long wire. This one looks good. Same kind of 7/16 of an inch or so. And we'll stick it in and hope. There we go. So that is step 27. There's only a couple things left here. We have, well, there's C16, there's this jumper here, and two integrated circuits. Just collect all of these. I think we're done with them, but I'm still not going to throw them away. Throw them away at the end, not when I think the end is. Okay. They are being very, very careful to remind me. U1 goes right here. It could fit there, but we want it to go right here. So this is an operational amplifier. It will go like this. So I will pull it out and plop it in right here. Maybe I won't. Okay. Here we're getting to the part where my fingers are too big for the board. Okay, there we go. Now, I'm gonna gently try to push these pins in by just a little bit. Each one by just a little bit until the LED, come on, man. Until the IC just pops in, just like that. There we go. And send it home. Starting to near the end here. Suppose I should explain why I'm making this, huh? I have an APRS station. It is a digipeater / iGate. There we go. And it is currently running off of a mobile-linked TNC, which is kind of overkill for what I'm doing. And frankly, I would like to have it back so I could do other stuff with it. So this will become the TNC for that. Okay. U4. Now the one thing... Okay, I guess... it concerns me a little that we got these little jumpers here, and apparently we're just covering right over them. But that's okay, I guess. Unless they go in at the end. Note the extra header pins, J5, underneath where it's installed. These are for an optional header to be used if the Dino TNC will have a TTL interface and a separate 5-volt source. This could be handy for an embedded project. Okay, I'm not doing that, so I think we're good. Yeah, we're good. Here we are, U4. This is a USB interface chip. Just from the name of it, I can tell this is the kind of chip that you, before grabbing onto it, you make sure to put on rubber-soled shoes and you rub your feet as hard as you can across the carpet and then touch a doorknob while holding it for good measure. In fact, if you can kind of touch it to the doorknob, that's the best. All right, this little dot here goes this direction. This is where we watch Chris's fat fingers do Chris's fat finger things. This is asking an awful lot out of my manual dexterity. Ooh, look at that! I got it. I'm proud of myself. A little bit. There we go. Send it home. If anybody is counting, we are on step 29. Okay. Back end of that wants to come up. Okay, here's what I'm going to do. I'm going to send this guy home. Loosen it. There we go. Now I'm going to send this guy home. And now I can just do the normal thing. 1, 2, 3. There's step 29, and now step 30. I have no idea why C16, this is the one they told us about earlier. There it is. Why we're putting it in now, I don't know. I'm saying it is in the receive audio, serves to remove DC offset from the received audio. Makes sense. If this part is missing, there will be no receive audio. See schematic below. Yeah. There definitely will not be any receive audio if this is not here. So I don't know why they had me wait. Not clear why they had me wait. There we go. And step 31. Okay, so this one they taped shut. It's this game called How Many Different Ways Can We Close the Bag? Oh, how about if we put a bag inside a bag? And then we tape it shut. No, they gotta have a reason for it. I don't know what it is, but there we go. This sits in here. Oh, come on now. There we go. All right, I'm just gonna send this home and then I think we're done. I'm gonna switch tips for that one. Apparently I can solder two at once like this. Oh, fine, I won't switch tips. Just goober a whole bunch of solder in there. There we go. Same thing over here. Okay. So here we go. All that's left now is testing. I do see J2 there. It does not appear to be there. So I'm going to take a look at that. But past that, here we are. Looks to me like a finished TNC. Let me just search in here. J2. It says nothing about J2 in the entire thing. Jumper. Let's keep looking. All they're talking about is these jumpers and ground. So, okay, fair enough. So here it is. I won't bore you with the last set of tests. It is a long set of stuff. But here's the Nino TNC. I'll report back.
So good news. I went through all the tests and it worked. Well, I'm lying a little bit. It didn't work for a second until I realized I had only partially snapped down the CPU. So I gave that another good push, and then everything passed with flying colors. So, as I mentioned before, I've got an APRS station. It is currently jimmied together with, well, it's a Mobilink TNC, a Raspberry Pi, a FT1500M, and cheap Amazon power supply. So I'm kind of wanting to consolidate that all a little better and make it into a nice little package. So this is going to be part of it. Look forward to that in future builds. Another future thing is, because I've got that APRS station, it's on basically a 1-inch diameter pipe going about 25 feet into the air. Yeah, that kind of needs to get grounded. So that's another video that's coming up. But anyway, if you like this kind of thing, I know it was a longer video, well, a super long video. If you enjoy just watching a dude solder, please feel free to hit the like button, subscribe. Let me know your thoughts in the comments below, and we'll see you on the next video. 73.